An equatorial mount is basically an as-L mount that's been tilted to point to the North Star so that the Earth's rotation can be accommodated in just one axis. You can convert your as-L mount to an equatorial mount by placing it onto a wedge. To help you align your mount, you want that wedge to have some kind of adjustment and tilt up and down, and also left and right. If you think of that wedge as an as-L mount, then an equatorial mount is one as-L mount on top of another as-L mount. The bottom as-L mount is used for polar alignment and then locked into position. Then your top as-L mount become your right ascension and declination axes. How accurately you want to be polar aligned depends on whether you're going to use the telescope for long exposure astrophotos or just low power visual use. With a setup like this, I would just set my tilt to my latitude and then plop the telescope down so that the RA axis is pointing more or less north. Then I can track objects across the sky in just one axis. If I'm not perfectly polar aligned, occasionally I'll have to make an adjustment in declination. In this video, I'm going to show you how I do a polar alignment of my CGM 800 telescope. I use Celestron's All-Star Polar Alignment feature, which is built into the NexStar hand controller. This polar alignment method can be done on other NexStar mounts, such as the NexStar SE scopes, like the popular 8SE. If you have one of these SE scopes, though, you won't find this in the manual. If you have the 5SE, which has a wedge built into the tripod, you'll find that the manual still describes something called wedge align, which was removed from the firmware years ago and replaced with the All-Star Polar Alignment option. This is my CGM tripod. It has this alignment peg, which is used to adjust polar alignment in azimuth. The tripod needs to be positioned so that this is on the north side. It doesn't have to be perfect, but if you're off by too much, then later you'll have to pick up the tripod, rotate it, and set it back down. The problem is you won't know that you're off until after you attach the 41-pound mount, so it's nice to get it right the first time. This is the 41-pound mount. You can see the part of the mount that rests on the tripod. And there's some azimuth adjustment screws which have been opened up so there's a big enough gap for the alignment peg to fit through them. You can see that once it's on the tripod, there's a little bit of motion in azimuth. But before I continue, I want to connect this center pin to the mount to eliminate the chance of knocking it off onto the floor. I have to be careful not to tighten it completely because then there won't be any adjustment in azimuth. As you'll learn, this is a poor design because you want the mounting knob to be completely tight when you're done, but the act of doing that causes things to move. These azimuth adjustment screws cause the thing to move in azimuth. Once we're totally polar aligned, both of these will be tightened up against the peg from both sides. Also, the mounting knob will be tight, and also the accessory tray knob will be completely tightened. I mentioned previously that you might discover during polar alignment that your azimuth alignment peg is not sufficiently to the north and that you have to lift the tripod with the heavy mount and turn it. Well, that's if you're lucky. If you discover you have to turn the tripod during All-Star Polar Align, then you've already added the counterweights and the OTA and everything else. For me, that would be way too much weight, and I'd have to tear it down. That's one reason I'm glad I got the polar alignment scope. It doesn't come with the mount. It's an optional accessory that you have to buy for like $40. It's a little telescope that goes right through the middle of the RA axis. When you look inside, you see a reticle, and inside the reticle is a cartoon picture of the Big Dipper and Cassiopeia. In the northern hemisphere, one of those will always be above the horizon. It also has something for the southern hemisphere. When you look through the eyepiece, though, the field of view is much too small to see the Big Dipper or Cassiopeia. So the way it works is, let's say the Big Dipper is at the 1 o'clock position relative to the North Star. Then you would rotate the RA axis until the cartoon image and the reticle is at the 1 o'clock position. Also on the reticle is a circle, and on the edge of that circle somewhere is a little circle. And you move the mount in as and L until the North Star, Polaris, is centered in that little circle. And that's how you polar align with the polar line scope. Now you can get better accuracy with all-star polar line, especially if you do it multiple times. And if you have the polar alignment scope to get you started, you can do it one less time. And that's the main reason I like having it. Now I mentioned moving this thing in azimuth with these adjustment screws here. Elevation is done with this screw here in the back. But before you turn this knob here, you want to undo the elevation locking bolt. Turning this knob here clockwise moves the mount up in elevation. But moving it left doesn't do anything because there's so much friction in the mount, you have to pull it down manually. So you want your final movement in elevation to be going up. If you overshoot where you want to be, then you got to go back and try again. Eventually you'll have the as and L of your mount polar line. You tighten down the locking bolt for elevation, the azimuth adjustment screws, the mounting knob, and the accessory tray knob. Before I turn on the power, I move the mount in RA and DEC to line up these index marks for each axis. And then I lock the clutch tightly for each axis. I would like to point out at this time that when we're polar aligned, it's this RA axis which lines up parallel to the Earth's spin axis, not the telescope. There can be a disagreement between these two. I think it's what's called cone error. Anyway, the computer figures this out, so your go-tos will be accurate. The reason I mention it is so that you won't be confused like I was and think that you should be able to get good initial polar alignment with the scope in this configuration. It works, but only very crudely, and nowhere as good as using the polar alignment scope.
Now I do the initial star alignment. For this mount, I do a 2-star align. The mount picks 2 stars in the western half of the sky, and then offers me the choice of adding 0 to 4 calibration stars, which will be in the eastern half of the sky. For maximum accuracy, I do 4 calibration stars, and use an eyepiece with crosshair reticles. You may notice that I don't use a diagonal. I worry that it just adds more wobbly bits and opportunity for misalignment, although I haven't taken the time to experiment. I do use a diagonal for visual use, but that is about it.
Once you've done your initial star alignment using 2 to 6 stars, you can then ask the hand controller to display the polar alignment error. Press the undo button multiple times to make sure you're at the top of the menu tree. Press the align button, and that will enter the align menu. You scroll through that until you get to see polar align. Under that, there are 2 options, align mount and display align. We choose display align, and it shows us the polar alignment error. If you want to minimize that, then we can do all-star polar align. And the first thing we want to do is to choose the star we're going to use. Now you might think with a name like All-Star Polar Line, you could pick any star in the sky. But as you'll find out, you'll be lucky if you have one acceptable star. The manual says choose a star that's high in the sky. They don't want you using stars near the horizon because the atmosphere bends the light on those stars. It says don't choose a star that's directly overhead. And you can see why that would be. If you have any error in azimuth, you won't be able to detect it with a star directly overhead. For the same reason, it says don't use any stars to the east or to the west, because you won't be able to detect any error in elevation with those stars. Finally, the manual says don't pick any stars near the celestial pole. So we can't even use Polaris to do the polar alignment. What I do is I get on my PC ahead of time to choose the alignment star to see what's going to be out there just after sunset, near the meridian, about 45 degrees above the horizon in the south. I've done that, and it's Antares. Then the manual says to slew to any star that's in the database. What it means to say is use go to. If you just use the arrow buttons to go to the star, then it won't know what star you're talking about when you try to do the all-star polar line. So I'm going to do that now. I'm just doing a normal go-to to Antares. Okay, so now I've done the initial star line, and I did a go-to to the star I'm going to use for polar alignment. And now we can go back to the menu, polar line, and this time we'll choose Align Mount. It says Slewing to Antares. It wants you to do the same thing you did with your initial alignment stars. Center the star in the finder scope, press Enter, center the star in the eyepiece, and press Align. It says Sync to Antares. The message now says Polar Align, beginning process to align mount to the celestial pole. Press Enter to continue. Okay. Slewing to Antares. This time though, it won't be at Antares. It'll be offset by the amount of error in your polar alignment. And the message says Adjust Mount. Do not use the direction buttons. Adjust altitude and azimuth settings to place star in center of eyepiece. Press Enter when you're finished. So we're going to physically move the mount in as and L to get the star centered in the eyepiece. It's kind of handy to have a green laser pointer for your finder scope, because then you can see where your telescope is pointed without having to have your head back here all the time. But ultimately you're going to want to center the star in the eyepiece and have everything locked down. Then we press Enter and we're done. It says Polar Line Complete. Let's see what our error is. Polar line, display align. It says we have perfect alignment, totally zeros all the way across. Well, that's all the computer can do. Assume that you did everything exactly right. If you want to know your true polar alignment, you need to turn the power off, start all over from scratch, do your initial star alignment, and then have the hand controller display the polar alignment error. Like I said before, if you want high accuracy polar alignment, you need to do the procedure multiple times, and that your polar alignment scope will minimize the number of tries you have to do. When I use the telescope for visual use, I just use the polar alignment scope. If that's not an option, then I would just use all-star polar line the one time, and once it said I had zero error, I would just continue from that.